So we're going to solve some multi-step equations. The first thing we really want to think about is, are these equations linear? A linear equation will have just a single variable with an exponent of 1, or it'll have two or more variables, but all of the variables will have exponents of 1. So we're talking about things like 2x plus 3 equals 7, or x plus y equals 5. So we may either be doing a system of equations, or we may be solving just a single linear equation for a variable. When we solve linear equations, if we are solving a single linear equation, like this guy, we will always follow very similar steps. Our goal when we solve an equation is to get the variable alone. That's our goal. We can do 1,000 different things to any equation to get the variable alone, but our goal is still the same. If we're solving a simple equation like 2x plus 3 equals 7, I'm allowed to do anything. Remember the golden rule of algebra? Whatever you do on one side of the equation, you have to do to the other. Well, I can do anything I want to both sides of this equation. I can add 8. Does that help me solve my equation? No, but it's a legal move. So we want to pick legal moves that do our goal. Remember, our goal is to get the variable by itself. And in this case, the variable is x. We always want to undo it in the order it was done. So the order of operations would say to multiply and then add. That's the two operations that are happening here, multiplication and addition. But we're going to undo it backwards. So we're going to undo addition, and then we're going to undo multiplication. And in order to undo it, we do the inverse operation. The inverse operation is what makes a thing go away. So the inverse of addition is subtraction. So I subtract 3 from both sides. When I subtract 3 from both sides, these 3's on the left-hand side cancel out. Those are gone because 3 minus 3 is 0. But on the right-hand side, I combine my like terms, and 7 minus 3 becomes 4. Then I bring my 2x down, and now I have 2 times x equals 4. Now I want to undo multiplication, and to undo multiplication, the inverse of multiplication is to divide. So we're going to divide both sides by 2. So x is equal to 2. Now you can always go back and plug in your solution to see if it works. So if I plug 2 back into the original equation for x, does that work? Is 2 times 2 plus 3 equal to 7. Well, this is 4. Now I go in order of operations. So we multiply and then we add. So 2 times 2 is 4, plus 3 is 7. Hey, that works. So I can always check my work. This is the very basic, simple explanation of how we solve equations. When we are solving multi-step equations, we have a lot more work to do generally when we're solving a variable on both sides or when we have to simplify first. So let's look at a few problems like that. Okay, so if we were going to solve this equation, the first thing that we would do is combine like terms. So these guys are our like terms on the right-hand side. So negative 11 would equal negative 4x minus 11. Now I want to isolate the variable, so I want to get x by itself. So I would add 11 to both sides. Remember, I go opposite the order of what I would normally do. So I would normally do multiplication and then addition or subtraction. So I'm going to go opposite. I'm going to do the opposite of addition or subtraction first. What I do on one side, I do on the other. And that's going to give me 0 over here and negative 4x over here. When I divide by negative 4, I get 0 is equal to x. I can plug back in to check my answer if I need to. So for this one, since there's nothing that I can combine, I'm going to distribute. And it doesn't really look like there's something I can distribute, except that there's a 1 here, even though it doesn't look like it. So that negative acts like a negative 1. So I can actually distribute that negative 1. So we're going to multiply negative 1 times 5, which is a negative 5, negative 1 times 3x, which is a negative 3x, and just bring the rest down. Now when we have variables on both sides, we can do whatever we want to both sides of the equation, as long as we do it to both sides. And we want to line up the things that are the same. So for example, I'm going to line up the plus 3x with the 6x over here. I could have just as easily added 6x to both sides instead, as long as I line it up with its like term on the other side. Since I move all the x's to the left side, I want to move all of the numbers to the right side. So I am going to add 5 to the right side. This is how I do it all in one step and save myself some time. Those cancel and those cancel. I end up with a 3x here and an 18 here. Now I can divide both sides by 3, and I get that x is equal to 6. All right, and now one of our really most difficult types of problems. I've got lots of things I can do in the first step here, and the first thing I'm going to do is start by distributing. I'm going to distribute the 6 only inside the parentheses. I'm going to ignore that negative 6. In fact, that negative 6 is just going to come down with me. I'm going to do the same thing with the 8. I'm only going to distribute it inside the parentheses, and that negative 8x is just going to come down. So when I distribute, I end up with 6x plus 48, and then equals 56x minus 24. Now when I look at this, it looks pretty confusing, but I can start to combine like terms. First thing I notice is 6x and negative 6x will cancel. So that's just going to give me a 48. And then I've got 56x minus 8x, which gives me 48x minus 24. Now when I'm solving this equation, I'm looking for who is all by themselves. So this guy over here is a number. So I want to move its friend, the other number, over here to be with it. So I'm going to add 24 to both sides. When I add 24, I end up with 72 is equal to 48x. And then I need to divide by 48 on both sides. When I divide by 48, I end up with 1.5 is equal to x. That's a legit number. I could also make that 3/2 if it needed to be in a fraction. All right, and then the last type of problem that gives us some trouble sometimes are these ones that have fractions in them. I always say the first thing I want to do whenever I have a fraction is get rid of the denominator. Get rid of the fraction. So multiplying by 8 will cancel these guys out, leaving me with just a plain old 15 minus x on the left-hand side. And then I'll have to distribute this 8 on the right-hand side. So that makes 8x minus 48. Now, I like adding better than I like subtracting, so what I'm going to do here is I'm going to get my like terms together. I'm going to add x to both sides, and then I'm going to add 48. What that's going to do is it's going to cancel out the x's here and the 48's here. So I'm going to end up with 15 plus 48, which is 63, and 9x, and so 7 is equal to x. So hopefully that gives you enough information that you can get started on solving some more complex problems.